Hello everyone and welcome to today's Crush the MCAT lesson on estimation and rounding. Whenever we're doing MCAT math, the two most important rules are to always check your answers first and to always round. Remember that the MCAT is a multiple choice exam, so the work you do to calculate your answer should be based on the answer choices you have available to you. In addition, the MCAT will never ask you to calculate a precise answer, so rounding is imperative to save time and make sure you always have accurate answers. You should keep a count of when you round up and when you round down, and try to keep that count balanced. For example, if we look at this equation, 7.7 times 2.3, if you round this number down, you should round this number up, or you can only round one of the numbers, and that will keep your calculation closest to the correct answer. If you rounded up more than you rounded down, your answer will be less than what you calculated, and if you round up twice, it will be much less than what you calculated. If we round 7.7 up to 8 and 2.3 up to 2.5, then our answer will be 20. The true answer for 7.7 times 2.3 is 17.7. Because we rounded up twice, the true answer was much less than the number we calculated, which was 20. If you round it down, the answer will be more than what you calculated. And if you round down twice, it will be much more than what you calculated. Going back to our example, if we round both numbers down and do 7.5 times 2, we'll get 15. In this case, the answer, 17.7, is much more than 15. So it's important to keep a rough count of when you round down and when you round up, and try to keep those counts balanced. Or try to round as minimally as possible, but remember to always make your math as easy as possible too. This will come with practice. Estimation and math in general get a lot easier if you have a strong grasp on the fundamentals. Fractions, percents, your times table, and scientific notation too. If you don't already have a strong grasp on all of these fundamentals, I highly encourage you to watch our lessons on these. Let's talk now about the two best strategies for rounding. The particular strategy you use depends on the answer choices you have available to you. Looking at this first one, we can see all of the scientific notation in this question is the same. All of these numbers are times 10 to the negative 6th. Because of that, we can ignore the scientific notation in this question. In addition, any scientific notation we might want to use in our calculations can also be ignored. I call this looking at the base numbers only. Let's say we set up our equation and we're ready to solve for the final answer. And this is the equation we have to do. We have to find frequency, which is 1 divided by 8.26 times 10 to the 5th seconds. Now remember, we can completely ignore scientific notation here. So what's the easiest way to do this calculation looking at the base numbers only? I think the easiest way to do this question is to transform it into frequency equals 100 divided by 8 hertz. From our times table and our strong understanding of fractions, we should have memorized that 100 divided by 8 equals 12.5 for a final answer of 12.5 hertz. Looking back at our answer choices, there's only one which is close to 12.5, and that is answer choice A. It's written here as 1.21, but you could just as easily write it as 12.1 times 10 to the negative 7th hertz. Since we're ignoring scientific notation here, 12.1 and 12.5 are basically the same answer, and this makes answer choice A our final answer, and that is the correct answer. Again, I want to emphasize this here. The MCAT will never ask you to calculate 1 divided by 8.26 times 10 to the 5th. It does, however, expect you to know 100 divided by 8 is somewhere around 12.5. And that's why when you get answers like these, you should just do the calculations with base numbers only. Sometimes we'll get answers that differ both in the base number and in scientific notation. Here we can see that A and B are both 3.23 and C and D are 3.54, but A and C are multiplied times 10 to the negative 1st and B and D are not. Because of this, we have to take into account all numbers in our equation. But we can still round and we can still use logical shortcuts too. Here's another example final equation we might have before we solve for our final answer. Notice here that we have 3.54 in our equation, which is the same number we have in answer choices C and D. Also notice we're multiplying 3.54 by one number and dividing it by a different number. This means whatever base number we get from this equation, it can never be 3.54. Therefore, we can get rid of answers C and D because the base number in those is 3.54. So we can assume now the base number we're going to get from this is 3.22. Now, how do we choose between A and B? Well, there are a few ways you could simplify this equation. One way I would do it is to simplify all the numbers in this equation, since we already know the base number of the answer. We can change this equation into a much simpler form by aggressively rounding all the numbers down to very simple numbers. 3 times 0.01 divided by 0.1, or 3 times 10 to the negative 2 divided by 10 to the negative first. Simplifying that, we get our final answer of 3 times 10 to the negative first, which most closely matches answer choice A. And that is the correct answer. Again, I want to emphasize here, we solve this question by using logical shortcuts and the process of elimination, and by making the math as easy as possible for us through aggressive rounding. Let's do some practice questions together now so I can give you a better idea of how to utilize these strategies. For our first equation, notice all of our base numbers are different. Therefore, we can ignore scientific notation. Because we can ignore scientific notation, we can aggressively transform these numbers into a much easier equation. Let's change these numbers into 1 times 3.4. With that, it's clear the base number of our answer choice has to be around 3.4, and the closest answer to 3.4 is C, 3.54, and that is the correct answer. For this next equation, we can round these numbers into much simpler ones. 176 can be rounded up to 200, and remember, if we rounded this up, we should round this number down. So 23 can round into 20, and then we get our final answer of 4,000. That's closest to answer choice B, which is our correct answer. This next one is rather difficult, and I would personally use a fractions approach to solve this. First, I would round these numbers into more manageable numbers, like 24 times 0.025. Personally, when I see a number like 0.025, I notice that it could easily be transformed into a fraction. The fraction form of 0.025 is 1 over 40, because 0.25 is a quarter, and if you make that smaller by a factor of 10 to the negative first, you need to multiply the denominator by 10 as well. Notice now that all the base numbers of the answers are different. Therefore, we can ignore scientific notation, and this equation becomes as easy as 24 divided by 4 equals 6. 6 most closely matches answer choice B, which is the correct answer. There's two ways of solving this next one. The first is you could round aggressively and see that 4 times 5 is 20, which would bring you to answer choice A. Or in case you worried you rounded down too much, you could round just one of these numbers. 4.1 times 5 equals 20.5. In either case, both of these answer choices are closest to answer choice A, which is the correct answer. You can approach this question the same way, but be careful, because if you were to change this into 2 times 4 equals 8, that would lead you to the wrong answer choice C. For questions like this where the answer choices are very close together, it's better to round only one number. In this case, if we do 2.2 times 4 equals 8.8, we can see that our answer is closer to answer choice D, which is the correct answer. So remember, for these ones that are very close together, try only rounding one number to keep your math easy, but also to be as close to the final answer as possible. And that concludes our lesson on estimation and rounding.